Good afternoon, because I'm recording this in the afternoon. This lesson is for pre-algebra, chapter 5, lesson 6, lesson 9, powers of products and quotients. So we're applying what we know about powers, which would be exponents, to multiplication and division problems. So that's what products are. Products are answers to multiplication problems, and quotients are answers to division problems. So let's say we have a multiplication problem that is raised to a power or has an exponent. This is very similar to the distributive property. So what we're going to do is we're going to simplify the expression by eliminating parentheses as much as possible. All right, so let's say we have 5 times 3 to the fourth power, which is the quantity 4 times 3 to the fourth power. There's two ways we can do this. We can do parentheses first, which would be 5 times 3, which is 15, 15 to the fourth, or we can distribute the exponent to the 5 and the 3. Both of them are going to give us the same answer. We're going to get 50,625, and I definitely used a calculator for that. There's no way I'm going to do 15 to the fourth power and sit here and show you all the work, because that'd be ridiculous. But if you also did 5 to the fourth power, which is 625, times 3 to the fourth power, which is 81, you're also going to get 50,625. Go figure. So here's another problem. We have the quantity 4 times x squared to the third power. We can distribute the third power, like so, and we need to distribute the third power to the x squared, which is then x to the second to the third. Now, if you remember from a couple chapters ago, when you have a power to a power, basically an exponent to an exponent, which is the case here of the x to the second to the third, you multiply the exponents. You don't add them, you multiply them. So it's going to be 4 to the third, which is 64, times x to the second to the third, which is x to the second times the third, which is then x to the sixth, because 2 times 3 is 6. So we have 64x to the sixth. All right, next problem, we have negative 2y to the fourth power. So we're going to distribute the 4, which is negative 2 to the fourth power. And see how I keep the negative 2 in parentheses? That's because the negative on the 2 is in the parentheses from the original problem. I will show you another problem in just a minute where the negative is outside and how that can change the answer. We also have y to the fourth. So negative 2 to the fourth power is negative 2 times negative 2 times negative 2 times negative 2, which is 4 negative 2's, which is negative 2 times negative 2 is 4, negative 2 times negative 2 is 4, 4 times 4 is 16, and then 4y's is y to the fourth. So we end up with 16y to the fourth. And that's the answer to problem number 3. Now here's the difference between problem number 3 and problem number 4. Number 4 has the negative sign outside of the parentheses. So it's still going to be 2 to the fourth and y to the fourth, but the negative stays outside and is not affected by the exponent. It's very important that you keep track of that, because if you were to somehow get that negative into the parentheses like it was for number 3, you actually will get a completely different answer. So we have 2 to the fourth, which is 2 times 2 times 2 times 2, times y to the fourth, which is y to the fourth, and 2 times 2 times 2 times 2 is 16, 16y to the fourth. But since the negative is outside of the parentheses, you apply it last. So there you go. Instead of getting positive 16y to the fourth, we're going to get negative y to the fourth. And that's because the negative is only on the outside of the parentheses. All right. Next portion. Power, raising a quotient to a power. So that's a division problem. Just remember, fractions is a fancy way of saying division. So we're going to raise both the numerator and denominator to the power. This is also like the distributive property. We're going to end up with 2 to the 2/3 times 2/3 times 2/3, because it's basically whatever's right in front of the exponent happens that number of times multiplied. So if I have 2/3 to the third power, it means I have 3 2/3, which are all being multiplied. So since I'm multiplying fractions, I'm going to multiply all of the numerators and all of the denominators. 2 times 2 times 2 divided by or over 3 times 3 times 3. Well, 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. But here's the other way you can do it, and this is probably the more calculator-friend way of doing it, because you don't actually have to show the work to figure out how many 2's you need, is to just distribute the third power. The 3 it becomes 2 to the third power over 3 to the third power. Well, 2 to the third power is 8, 3 to the third power is 27. Same answer. Yay. All right. So next problem. Let's say we have a negative exponent, or a negative fraction. Well, that's fine. Now, you're going to notice that the answers are going to be slightly similar, but not quite. Also, if you had a negative here, and this, like, hypothetically, let's say that was negative, then your answer would also be negative, like so, because a negative times a negative is a positive, right? But this one would stay negative, and that would be a negative, and a negative times a positive is a negative. But remember, it was positive to begin with, so just remember that if it's positive fraction to the exponent, if it's odd, it's going to stay positive. But if it's a negative odd exponent, then you're going to end up with a negative answer. Okay, but since we have a even exponent with a negative fraction, we're going to end up with another positive answer. Okay, so this is the same as negative 2/3 times negative 2/3 times negative 2/3 times negative 2/3. A negative times a negative is a positive, and another negative times another negative is a positive, and a positive times a positive gives me a positive final answer. But let's go ahead and figure out what the numbers are like. We know that the answer is positive, but we haven't figured out what the actual numbers are. So that would be 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3, which is 2 to the 4th power equals 16, and 2 to the 4th equals 16, 3 to the 4th equals 81. And again, the other way you could have done it is just distributing like so, and known that a negative times a negative is a positive times a negative, which is a negative, times a negative, which is another positive, and gotten, therefore, 2 to the 4th over 3 to the 4th. Okay? All right, next problem. This is a multiplication problem inside of a division problem, which is then cubed. Yes, it is a crazy problem, but you can use it. You can do it. Just remember what you learned on the previous slide and can then combine it with what you know about a division problem. So we have the product on top, which is 2 times x to the second to the third over 3 to the third. So we're going to distribute the third power, 2 to the third times x to the second to the third over, let's hold on a second. Oops. Let's move this over and erase that so it's out of the way. Okay, so we're going to end up with that. So 2 to the third is the same as 16, and then x to the second to the third, you multiply the exponent, so it's going to be x to the 6th, and 3 times 3 times 3 is 27. So you're going to end up with 16x to the 6th over 27. All right. Let's see here. I believe we're on to the last slide. Okay. A few of you will see negatives on your work. Primarily honors people, you might see some negative exponents. Here's how negative exponents work. Basically what you do is you take the reciprocal and then turn the exponent into a positive. So the reciprocal of a is 1 over a. And then notice how I've turned the negative exponent, negative 2, into a positive 2. That's what you need to remember. If you want to know how it works, let's go, I'll show you real quick. And then obviously you can pull out the squared, because what's 1 squared? 1, doesn't matter that the square goes up there. Okay, so here's how it works. If we have a over b to the negative n power, the negative n tells me to drop the a over b under 1. All right, because I'm taking the reciprocal of a over b. The reciprocal of a over b is 1 over a over b. The n becomes positive. Then I distribute the n. Now, how do I divide fractions? Well, what is this? Well, it's just 1 divided by a to the nth over b to the nth. Now, because I'm multiplying exponents, I need to multiply by the reciprocal. The reciprocal of a to the nth over b to the nth is b to the nth over a to the nth. I'm right here if you're having trouble following along. I'm right there. All right. Now, well, what's 1 times a to the nth over, or b to the nth over a to the nth? Well, that's b over a. And then since the nth is happening on both, we can actually just pull it out. There you go. So that's how we get from a negative nth power to a positive nth power, and the reciprocal happening. All right, so just remember, if you have a negative exponent, take the reciprocal of the base, which is the bigger number or the fraction, and the positive of the exponent to create the new power. So, all right, I'm done. This last part is a little confusing. Mostly honors people will see this. For sure, though, you're going to see this in Algebra 1, so if you can learn it now, you'll save yourself almost an entire chapter of heartache in Algebra 1. So definitely try to learn it now. All right, bye, guys.